Thank you, TJ. But TJ, I did have one question or clarification on one thing you said, and because it caught me as slightly misspoken, I guess.
Okay.
Over a 20-year period, all right,
Yeah.
a cubic foot of methane released into the atmosphere. I think the way you said it was it's 85% more impact on global warming than CO2, but I think it was 85 times.
85
Because 85 times means 1 cubic foot of methane and 85 cubic feet of CO2 have the same impact on the environment. So
Correct.
So I just
100%.
want to make
That's
sure
right.
that
85x.
That's what you meant. All right.
Yes.
All right, let's go into the Slido poll. It's a very simple poll. Let's see if we can get it up there. All right, it's working. All right, that was the question, and that is not the Slido poll that I need. All right. All right, this is not a cloud. All right, Slido. All right. The question was just rate these three items: upstream, midstream, and downstream. All right, and let's just have we can get a vote here. Only you guys are probably voting anyway. If you think the most emissions were from what's that? Yeah, you probably saw it on your own phone, right? So it was upstream, downstream, and midstream. Yeah. That seemed to be consistent with what we have. Obviously, we were talking here about a lot of upstream discussions about this, and so I'll open it up to the floor for questions. If you don't have any, I have several. Larry.
I assume that dark blue dot in your satellite map was the Permian Basin, right?
Yeah, the Permian is yes. Yeah. And the Permian is interesting because you can, in certain circumstances, you might have actually relatively low emitting assets, but especially because of the fact that we, in a lot of cases, haven't had, we've had to rely on flaring. There's venting, not necessarily easy evacuation routes for the gas. They can be quite high emitting as well.
I drive through there twice a year and it stinks.
Yeah.
So what can we do to stop emissions in those kinds of applications? I mean, what are the primary opportunities to reduce emissions?
Yeah, sure. Well, if you think about I like to think about it in terms of like what we would call a marginal abatement cost curve, right? So what is the cost of abating any particular unit of methane? And what is fascinating is that actually there are a lot of abatement opportunities that are in the money, right? You actually can make money by doing it, because you can monetize that. And there are simple things like dealing like swapping out pneumatics pneumatic devices that are emitting, and there are a wide range of other different technological fixes that can quite significantly help addressing. But emissions visibility and measurement are really key, because if you can identify a high emitting event quickly and tackle it, it's not simply just leak detection and repair, but identifying super emitting events and tackling them quickly, that can really help to curb emissions overall as well. Yeah, so there's a range of technologies. A lot of them are sort of profitable today if they're implemented, and a lot of it has to do with also just being able to better understand your facility with different forms of measurement technology. But I don't know if you have any more.
Yeah, sure. I mean, I think the key is to identify the leaks, right? And there's a lot of technologies that are there. Right now, they're not mature enough to predict leak shape. I mean, a lot of the organizations are working on that. But I think the key again is to start from monitoring and trying to figure out where or at the asset level are those leaks coming from, and what can be done, whether it's conditional based maintenance, for example, at your asset level that will prevent these kind of leaks from happening. There are a lot of other things that we are looking towards of integrating these kind of leak data into the overarching production workflow itself to figure out what can be done to mitigate that even before the leaks start happening.
And if I may add to what they just said, so Permian Basin is, that interestingly you bring out. So I read last 2022, within the first 3 months, the first quarter itself, there's been over close to $1 billion of emissions, billion cubic feet of emissions. And this is all due from the non-routine flaring and flaring. So from flaring alone, there is so much of emissions. And so basically non-routine flaring is nothing but unreliable or faulty structures or equipments. So I think using technology like predictive maintenance and all that can help ensure better upkeep and maintenance of your equipment, thereby reducing emissions and therefore the non-routine. And for the routine, of course, since it's predictable, I think some added infrastructure, like TJ said, added infrastructure of gas processing and the storage and transportation of that, you can actually monetize it. So instead of emitting, you can, it's profitable as well as, helps the climate.
So before we go on to the next question, I just wanted to introduce Vinky, all right, because you may not understand the relationships here. He is a supplier to Weatherford, and I know that you do a lot of IT and data analysis. How is it that can you explain who L&T is and then what your relationship is to Weatherford and what did you help them do?
Sure. Thanks for that. Thanks for that opportunity, Rick. So L&T is a pure play engineering service provider. So what we do, I'm the vice president for industrial and OFS sector. So what we do specifically for the OFS segment, and if I talk in conjunction with today's topic, is on the predictive analytics, sensorization of equipment, so thereby creating digital twins. So we are, as I speak, we are running several of these initiatives along with our customers, and in the process, of course, we talk about reduction of cost, reduction in operational cost, because they're making more predictive rather than periodic maintenance, so whether equipment needs them or not. But then we also helps with the emissions. So we do have the conventional core mechanical engineering, hydraulics, electronics, downhole, high temperature electronics, and all of that. And then, of course, we also have the AI, ML, and the digital solutions aspect that helps, helps our customers enable their journey of the IoTization or sensorization of their equipments to a connected future.
Thank you. Dick Slansky.
Where do residential emissions factor into this overall picture? In other words, home heating, use of gas ranges, which seems to be a little controversial right now. But and I don't know if I would include businesses in that either. I mean, in terms of heating, but I mean, have you broken out maybe just residential as a sector?
That's a great question. I think that I don't have hard numbers on this, but I think that what is becoming clearer is that there is actually significant methane leakage within homes as well. I think it's hard to kind of put a number on it, but I think we're realizing that it's a bigger issue than maybe we had expected, which is consistent with the trend around methane in general, right? The more you measure, the more you realize that there's methane there. And so, it is also one great near-term opportunity to electrify. We talked a lot about sort of electrification, putting in heat pumps and electrifying your home heating and cooking are relatively low-hanging fruit, and can be both cost-effective and also yield other benefits, including to health. There's been a lot of focus on.
Do you differentiate between leakage and combustion?
There is a differentiation for sure, and that is where sort of the global warming potential question comes into play too, right? That if you're burning it or flaring it as opposed to venting it or leaking it, then that has a different climate effect. One of the really interesting things about flaring is that there still is a significant amount that goes non-combusted even in a flare. So that when you're looking at incomplete combustion and flaring, as part of flaring, that can actually, that can actually mean that it's pretty high emissions from there as well.
It's interesting. I think also on the homeowner side is, we have a lot of mini splits showing up, and these mini splits occasionally can leak, and those are HFCs. All right, those HFCs are greenhouse gas, so they're, obviously we've changed the refrigerants from from the Freon R12 to a much less greenhouse gas potential refrigerants, but they're not zero.
And they're higher. They're also short-lived climate pollutants like methane, pretty high emitting.
Oh, is that right? For their, so
Yeah.
they have a
Yeah.
they have a big kick in the short term,
Yes.
and they tend to decompose.
Yes.
Yeah. Any other questions from our audience?
Align with your statement of you can really manage what you can measure.
Yeah.
Do you feel we should focus more on scope 1 and 2 rather than scope 3? I feel like scope 3 is so out of the realm of feasibility. Just
Yeah.
wanting to get your thoughts.
I'm happy to start with that if you want. I mean, so if we're thinking about it from scope 1 and scope 2 and scope 3 are all based on an individual's perspective or a company's perspective, right? So for the sake of this discussion, if we're talking about downstream and end use, I think that it's, this is something that we grapple with a lot, how to kind of explain this. But there is, demand side solutions are really important, right? And so that's why, focusing on the electrification of transport, trying to find alternatives to gas combustion in industry, electrification of buildings, all of those things are really, really important, but also they take time. And in the near term, especially when it comes to methane reduction, there's so much alignment. It's just a kind of a no-brainer. Like, let's get this done. And more generally, there's a question of like the what we would call the license to operate and the social license to operate in particular. And that's an issue where I think the oil and gas industry is pretty well aligned. They've all, most companies have set net zero scope 1 and 2 targets. Some are thinking about scope 3, but everyone's kind of agreeing on the need for net zero scope 1 and 2. So there's strong alignment there. But yes, it is a very good point that the demand side matters as well, and that's a sort of in some ways a collective challenge to be grappling with. But
Yeah, thanks. No, I think, you're right in terms of the heavy impact of scope 1 and scope 2, right? So in the examples that I was giving, right? So we are an energy services provider and we help our customers, so let's say Chevron or Exxon, reduce their scope 1, scope 2. But when we are creating our own equipment, which is then utilized to provide them services, if we get efficient on our side for our own internal purposes as well, that then effectively helps in reduction of scope 3, right? And more our customers are demanding us as energy services providers to make sure that we are reducing our footprint internally as well, so that then the scope 3 contribution that happens for them overall gets reduced. So yeah, the bigger impact is 1 and 2, but then I think from a holistic view, we have to look at the entire value chain.
And if I may add, I think one aspect that really hit me hard, and TJ just touched upon it. So the scope 1, scope 2, scope 3, as we see it, is not predetermined. It is so. If I take, for example, an owner, like for a Chevron, when you are buying their fuel and burning and emitting it, it is scope 3 for them. But from your perspective, it is scope 2. So therefore, you cannot say one is more important than 2 or 2 is more important than 3. So therefore, I think emphasis on all 3 at the same time is going to help us overall.
Overall holistic kind of way, yeah.
Peter.
Hi, Peter Manos with ARC. It's interesting to look at the oil and gas industry from an economic GDP contribution point of view, except it's very difficult. Like when you actually look at how industries are categorized by the U.S. Bureau of Labor Statistics or Economic Analysis, utilities is a standalone industry, mining. To actually identify the components of GDP that are oil and gas, you have to drill down in a very difficult way because part of it's in mining, part of it's buried in wholesale and retail trade. And so I'm just wondering if you've ever actually tried to back out that way and say, here's what part of the economy it is. Not the way the API does it with like a very fuzzy, 10 million jobs or 8% of the economy, but from a point of view of GDP value add.
Yeah, that's great. That's a great question. I've been thinking about it more from the emissions standpoint, but it's actually quite similar in the sense that, if you're thinking about it from a primary emissions perspective, so that pie chart I showed earlier, it's easily over half of sort of total fossil fuel emissions, total energy emissions. That maybe is the easiest way to kind of get to the extent of the contribution, even if a lot of the solutions are on the demand side when all the sectors are broken out and your Sankey diagram turns into spaghetti at the end, right? But yes, I think that it's much more difficult to kind of to factor in sort of what the overall contribution is from an economic standpoint. And I haven't done that myself recently, but it certainly would be something to look into further. Yeah. Okay. All right, that sounds good.
Question in the back.
So this is for Manoj and for TJ. See, how much of digitalization is going to help you in terms of reducing that and even in measuring it? So what do you see from the industry looking at from a digitization standpoint, both from the upstream, downstream, and the midstream side of it?
Sure. I'll take the part more on the upstream side, right? So when we think about digitalization, there are two aspects of it. The examples that I showed you were more of improving efficiency in the operations, which then eventually help in reduction of the carbon, right? But in terms of actual monitoring of each of these emissions, right, we don't have maturity yet in terms of accurately monitoring all of these emissions. And that's what the industry is working towards, to figure out ways in which we can efficiently monitor, let's say, methane leaks, or try to figure out where the leaks are actually coming from. What's the intensity of that leak? Since how long this has been happening? There are technologies out there that do that, with respect to cameras, etc. But they're not all of them are cost effective today. And that's where the next generation technologies that a lot of the people in the industry are thinking of right now are, how do we utilize cheap sensors that can be proliferated across the producing asset, for example, and use machine learning technologies to gather all that data to triangulate where these leaks are coming from. And then hopefully with that information and data, think about how prediction of the leak can also happen. So that's really where we are at right now. But majority of what I talked about was more of gathering the data so that you can improve the operations efficiency itself. And so it's the direct and indirect impact of what digitalization can do.
I can talk about it from the measurement standpoint. There is a significant challenge in that where digitization, or actually at the very least sort of using artificial intelligence modeling, et cetera, can be very helpful, because what you're seeing is we're taking snapshots, spatio-temporal snapshots of emissions at a particular point in time, and it is hard in place. And so you to get to the point where you can then with confidence say, this is the extent of the methane emissions from this asset at any given day or over the course of a year, requires a lot of harnessing of data, modeling approaches that can leverage that. That's one. The second one, which is almost completely different and closer to what we do in supply chains and Horizon Zero, is that we are trying to create digital enablement solutions to allow us to track and trace throughout a value chain the emissions, right? So what are the embodied emissions across an entire product? And where should those emissions be sort of allocated across the chain? And so using digitization to kind of to track and trace those attributes is something that we're really keen to continue to develop and advance. So I think that is ultimately will be a really important component of trading products and commodities as we get closer to some clarity on like a carbon pricing globally. So that's where we're doing a lot of work on digitization as well.
So kind of as a follow-up to this very good question, how actually do you measure and quantify that this many cubic feet per minute leaked from this flange. What are the instruments and devices? You can't use a chromatograph. You know, what kind of camera can see this and distinguish methane leaks from other components? You know, somehow you mentioned that satellites can look down, you know, from above on maybe only on a clear day though, right? Start with you, TJ.
Okay,
What do you know about the technology to measure methane leaks?
This is actually a really big deal in EPA rulemaking right now too. So historically, we've used OGI cameras, optical gas imagery cameras have been the main form, and what we're seeing is that there's growing technology with using aircraft with you know, tower-based sensors, with satellites, and they all have sort of different value propositions. They can have different detection limits, but they can all add value. And so what we're seeing is that we expected in the regulation that there will be effort to kind of better incorporate these different technologies. And the labs, the METEC labs in Colorado have done a lot of work in trying to assess and evaluate these different types of technologies. So that's kind of where especially in methane, I think we are, but yeah.
Yeah, I would support that. This is what we've been seeing, there's camera-based technologies that look at how much the emission is. I've also started seeing a lot of innovation in terms of small sensors that can be applied straight on the wellheads or near the assets to figure out how much that leak is. And then again, together with a combination of all different type of data sources, that's really where you know, the algorithms are now being put in place, so that you have data coming from different sources connected to the traditional flow measurement devices as well, where we measure hydrocarbon flow, and then combine that traditional physics-based algorithms with the data coming from these different sensors with ML to figure out what the intensity is and where that leak is potentially coming from.
I didn't have anything to add. Actually, I had another question to back up your question.
Okay.
So, TJ, on your presentation, you talked about it. Currently, you're doing you know, with aircrafts, and you're planning to launch some satellites.
Yeah.
Early next year. My question is already so many satellites already beaming down upon Earth, and you know, already, you know, capturing images. So why you cannot back up on those existing infrastructure and, you know, instead adding more satellites?
Yeah, well, so I think that we're still in relatively early stages of satellites that are mostly focused on emissions, with actually some others like methane sat, for example, coming out relatively soon too, and so I still feel like we're kind of in the earlier stages of this. The second thing is that satellites can have sort of take quite different approaches based on the technology that's used. So some can focus very, very, you know, kind of with pinpoint accuracy, but you know, they kind of lose the forest for the trees potentially in some ways. It can still be very useful if you can focus in on key point source emissions. Others take a broader, sort of a broader look. There's also the question of what is the minimal detection limit. And so that's why there's emphasis on, you know, super emitters, because maybe the minimal detection limit is higher, but you can actually, you know, you can have better coverage. And so there are kind of trade-offs and different technologies even in the satellite space. It's still evolving, but I would say, yeah, over the next couple of years, even in the next like 2 years, we'll see a lot of really interesting developments there.
I mean, from the sounds of that, it sounds to me like it's such a hard entity to measure methane leakage that we've probably been under-reporting methane leakage historically, and maybe some of these new sensor technologies are finding new leaks we didn't know we had. You know, I'm pretty sure we didn't find new places that the leaks stopped, all right, by themselves. All right.
Yep, that's 100% correct.
Yep.
All right, any last questions?
Do you have anything to say about flaring reduction initiatives? I know a lot of the
Yeah.
oil and gas companies have these programs in place to drastically reduce flaring. I'm interested if you have any comments on that.
So the World Bank has a zero routine flaring initiative that's been in place for quite some time, you do have significant commitments there. There's very strong. I think everyone has across the industry. Many, not everyone, but many in the industry have acknowledged that routine flaring is kind of is the minimum standard. Get rid of routine flaring for sure. So that is an important step toward getting to zero methane emissions too, acknowledging that flaring itself also includes incomplete combusted methane. I think that this broadening of the concept beyond flaring to include methane leakage more overall does not mean that flaring will suddenly become less important. It's still extremely important, and there's a lot of focus on some very high emitting countries from a flare standpoint, whether it's Iraq, Algeria, Russia. So yes, there's a lot of kind of effort to increase emissions visibility around them as well. So it's definitely still a key priority, even if it's kind of broadened in scope. Yeah.
Yeah, and I think what I'd like to add to what TJ is saying is, I think we saw in the slides as well, right? What are the technologies or what are the techniques that are being used to reduce that at the source itself? Like, one of the key challenges in upstream oil and gas is, for example, water production and disposal of the water, right? And we are trying to figure out, okay, there are a lot of companies that now look at how can I reduce the production of water itself instead of thinking about how to dispose it of. It's the same philosophy being applied now to flaring, where we are thinking of how do I reduce that methane at the source itself so that I don't have to flare so much. Mm-hmm. And again, this is a combination of traditional methods that we have, integrating all the data and trying to figure out what is that source and what operation changes can we do to reduce the emission itself at the first place.
And to add to that, I think there is already an initiative, there's a discussion in place. I'm not sure how soon they would come to a conclusion about a 16 billion cubic feet per day gas pipeline from Permian Basin to the Gulf.